We're going to be taking the derivative of exponential functions, and we're going to start with a function whose base is e. So we have f of x is equal to e to the 2x plus 1, and this is how the formula goes for finding the derivative with base e. So we have some function up here in the exponent, like 2x for example. That's going to be our h of x. We take the derivative of h of x, we bring it out front, and we just rewrite the whole thing. So here's an example. You take the derivative of 2x, and the derivative of 2x is just 2, and then we just rewrite e to the 2x. And that's the derivative of f of x. All right, looking at this particular one here, we've got f of x equal to x plus 1 times e to the square root of x. So we're going to use the product rule, taking the derivative of the first function, which is 1, rewriting the second function. Now you notice I get it from radical form and put it in exponential form here. Plus, and then the first function times the derivative of the second function, and the derivative of x to the 1/2. You take the 1/2, bring it out front, rewrite x, subtracting 1 from the exponent, gives us a negative 1/2, and then we just rewrite the function e to the square root of x here. And then I believe I factor the e raised to the x to the 1/2 out. No, I don't factor yet. Okay, I try to clean this up over here. This going into the denominator, because it's a negative, we drop the 2 down, rewrite x plus 1, and then e to the x to the 1/2. Okay, then I get a common denominator. I multiply the top and the bottom by 2x to the 1/2. So now we have a common denominator. I add the tops together, and then I factor an e to the x to the 1/2 out. Put things all back in radical form. And so this is the derivative. We got the function f of x is equal to 2 raised to the 3x. Now in this problem the base is not e, but it's an integer, happens to be 2. And if this is not e, then this is the form that we want to follow. You take the derivative, which is 3x. The derivative of 3x is going to be 3. You rewrite times then the natural log of 2. So whatever this is here for the base, you get the natural log of 2. All right, we have the function f of x is equal to x squared plus 1 times 6 raised to the x cubed plus 2x plus 1. So we're going to use the product rule again, taking the derivative of the first function here, which is 2x, and rewriting, plus rewrite the first function times the derivative of the second. Means you take the derivative of the exponent, you bring it out front, rewrite this piece here, the second function, and then remember we need to tack on the natural log of 6. So whatever this base is, we get the natural log of 6. Now you remember when base was e, if we wrote the natural log of e, you just get 1. So that's the reason we don't even write this. And then I think I try to clean it up a little bit here. What do I do? I think I just multiplied this stuff together here, and I believe that's as far as we want to go with that.